Hey there, this is MathCamp321 presenting the solution to question number 9 from the PARCC Algebra 2 practice test, school years 2014-2015. And in this question number 9, they're asking us to solve a system, a 3x3 system. And when I teach this at my school, the big thing to remember, I think, in solving a 3x3 system is being organized. Work can get all over the place and students often lose track of where they're at in the midst of the problem. So what I'm going to suggest we do to start is to label each of the three equations as row 1, row 2, and row 3. So I'm going to go ahead and do that now. The other thing I want you to notice is that in this problem, they're not asking us to solve the system entirely, they're only asking us to find the value of z. So we only have to do 1/3 of the work. So the next thing that I need to do is look at my coefficients and see which ones are going to be the easiest to work with in terms of eliminating one of the variables. And I think I'm going to eliminate x, and I'm going to start by adding row 2 and row 3 together. And I'm going to notate that in the following way. So I'm going to start with row 2, and I'm just going to write it over again. And now I'm going to write down row 3. And as indicated, what I'm going to do is I'm just going to add these two rows together. When I do this, the x terms are going to cancel out, and I'm left with 10y minus 8z is equal to -6. So I'm left with an equation in two variables now that the x has been eliminated. Now another observation I make at this stage of the game is that every term in this equation is divisible by 2. So my life can be made much easier if at this moment I divide every single one of these terms by 2, leaving me with a new equation that says 5y minus 4z is equal to -3. And this is the equation that I'm going to work with a little bit later on. Now I want to take two other rows to also eliminate x. And I think I'm going to use row 1 and row 2. But in order for the x to become eliminated, I'm going to have to multiply row 1 by 2. And I'm going to notate that in the following way. Twice row 1 plus row 2. Now twice row 1 means I'm going to multiply each element of row 1 by the number 2, leaving me with 2x minus 18y plus 8z is equal to 2. I'm going to do a rewrite of row 2, not doing anything to it. Again, the x terms are going to drop out, and now I'm left with -9y plus 4z is equal to -1. So I'm going to take the equation that I just arrived at, which is in two variables, y and z, and the first equation that I arrived at, which is in y and z, and I'm going to stack them one on top of the other over here on the right. So I'm going to write 5y minus 4z is equal to -3. And now I'm going to write -9y plus 4z is equal to -1. And when I add these together, these two equations, the y's are going to cancel out. And I'm left with -4y is equal to -4, which means that y is equal to 1. Now we actually didn't need to find y, we actually need to find z. So let's take that answer that we just came up with and let's plug it in. And I'm going to plug it in to this equation right here. So I'm going to say 5 times 1 minus 4 times z is equal to -3, or 5 minus 4z is equal to -3, or that -4z is equal to -8. And if I divide both sides by -4, I end up with z is equal to the number 2. And the question asks, what is the value of z? So it took a little bit of extra work to get there because I had to first find y, but in the end I was able to get z to equal 2. Again, 3x3 systems, think of organization. If you rush through it, you're probably going to make a mistake somewhere in the beginning, and then everything after that will be incorrect.